Yes, hello. So I'm Tino from KILT Protocol, and we heard a lot about today what you can do with blockchain, especially the things everybody talks about, DeFi, NFTs, but there's a lot more that you can do with the help of blockchain, and one of those things is basically regaining control of your data. Because I think you all know, we just gave up on it by making accounts at Google, at Facebook, our Apple accounts, whatever. So our data is not in our hands anymore. And KILT Protocol is there to actually solve that issue. And that's what I'm going to talk about. So now I'm pressing down. It's I can do so. It's working. It's okay. It's okay. I think it was a focus. I have focus on my speaker notes, and now the focus is there. Then now it's working. Okay. Yeah. So I have to go a bit into history to give you a little bit of context. So everything started with the invention of the internet, and we had those initial protocols. So there's the IP protocol, TCP, UDP, SMTP, you name it. And those protocols itself are a great foundation for the internet, but they don't add that much value, basically. They are important, but for users, if you just have the SMTP protocol, I doubt, I mean, okay, we are here in Web3, perhaps one or two people could send an email by hand, but I think the rest couldn't. The rest would just rely on applications which are built on top of that, what we call Web 2. So if you go to Gmail, that's a prime Web 2 application. So it builds on top of IP, TCP, SMTP, and HTTP to serve you a unified experience. You open a browser, you go to Gmail, and you write your email. And you don't have to care about IP, TCP, SMTP anymore, nothing. So there is a lot of stuff that got built in the Web 2 era, so search, we talk about Google. There's also storage and transportation, so there's a lot of value which is there, which is given to us by Web 2 companies. And that's not a bad thing, but yeah, it developed into the wrong direction. So there's a lot of value in there, but now we are basically one step further. We are, come on, that was the wrong button. Now we have Web 3. And the big distinction is we still have the base protocols, so the thin layer at the bottom, but then we have like a fat protocol layer, which is implemented by all our blockchains and our power chains, which provide a value to the user, but not in a really usable way. So if we think about Quast, for example, which provides a framework for storage, or in general, ownership, which is like the basis of all NFTs and ERC20 and whatever. And we also have like protocols for identity. This is where we came from. So KILT Protocol is about identity. And those protocols basically provide value by building a foundation where new dApps could be built on top of that. And on top of those fat protocols, there are then the real applications, so dApps. Basically, as an example, so there is, for example, from us, there is DID sign, where you can use your keys to sign files and send them around, and then the other person can be sure that the file comes from you. Or social KYC, where you can get credentials, or Piñata is also a service built on top of storage protocols. DAXs and all the DeFi applications, they are all user-facing applications which are built on top of the fat protocols provided by our blockchains. So this is basically the setup where we live in. And Web3 adds real value. Can I scroll up here? No, I can't. I will go back to like the analog version. That's always working. Basically, if you look at that, so we had that Web 2 in the beginning, and it solved some problems. So it gave us nice UIs, it gave us value because it helped us in our daily lives, because if you want to send an email, You don't write the SMTP messages by yourself and encrypt it by hand. No, you are just using Gmail. So, but the problem with that is all those functionalities are basically provided by big centralized companies. And to actually use them, you have to give your data to them. That's their business model. You give them your data and they give you a service for free. But as we all know, it's not for free, we are trading our data. But Web3 can actually really solve that and help with that because so common good functionalities, for example, identity, payment, and ownership are implemented in a distributed way so that there is no central authority which basically has power over that. And with the help of that, we can have the control of our data back in our hands because we hold the keys. We are the ones who have the keys to our wallets, which then prove our ownership of our tokens. We have the keys which encrypt our data on our own devices. So the ownership of the data comes back to us. And that's like a fundamental shift from Web 2 to Web 3. Yeah, and also when you are basically in the Google ecosystem, for example, not everybody can build an app on top of Google. I mean, yes, they have some SDKs and it's possible to integrate with it a bit, but you don't have the freedom to actually build on top of that. But with Web3, we have those fundamental free protocols, which can be used by any builder. Anybody here can just leverage that and build creative apps on top of it. And that's also a big difference. Yeah, and if you look at that, I think so the time will not go backwards. So Web3 is here to stay because, yes, we only have like 70K developers currently in Web3, but those people who had a look at Web3, they see the benefits of it. They see that they don't have to give their data to some central organization which then sells it. And that's why it's unavoidable. It's there and it's there to stay. Yeah, so what is identity? That talks about identity, and identity is who I am. So this is me, but identity is not only me, it's me, especially when others confirm it. So there are credentials. So here, for example, there's my ID card, there is my driver's license, for my health insurance, the card, Lufthansa, Senator card, and also I have a degree from a university that's also certified, and those are all like trusted entities which certify who I am, what I can do, and all those things. And yeah, but how does it currently in the real world works? So what is an identity transaction? An identity transaction is always when I want to prove my identity to somebody to have a benefit from it. So if you want to go to a concert also, you have to prove that you own a ticket. Or if you want to go, for example, to a liquor store and want to buy a bottle of alcohol, of nice scotch, then you have to prove that you're over 18. So how do I do that? I go to that store and then I show them, here, I have my ID cards with me, and I show them to them. Then the shop owner looks into my face and sees, oh, that's the very same person. So that subject equals the credential. And then all they have to do is they have to check if they trust the credential. So in the top line, there is written Bundesrepublik Deutschland, which says the state gave that to me. And there's my date of birth, which basically says I'm over 18. So and then they checked, and then they say, okay, this is Tino, he's over 18, he's allowed to drink whiskey. And then I can get my bottle of whiskey. That's like the normal thing in the world. But what are the benefits of that process? I mean, it sounds like stupid, I know, but it is like a super old concept, and it has a lot of benefits because it is not centralized. I will show you why. So basically, there is an asymmetric trust. So I trust my government that they give me like a credential, and the shop owner also trusts the government that they don't like issue passports to random people with random birth dates. So it is highly really scalable because the verifier, so the shop owner, he doesn't have to ask my state to verify that, that passport. They only have to look at the passport. So it's not like an OAuth where you first send a request to Facebook, which then creates a credential and sends that back to the person who wants to check what's your email, what's your identity. No, it's not like that. We get that credential once, and then we can show it, and there is no way that my government can say, Tino's a drinker. He went to the store and buys whiskey all day, because there is just nobody who, it's just not possible. It's not in the concept. And yeah, so the issuer is really not part of that identity transaction. The issuer just creates a credential in the beginning, gives it to me, and then they are out. And then I can just use that credential. And this is good for privacy, because I mean, I could also use my passport and prove that I'm over 18 to go to other locations, which I perhaps don't want to share. And yeah, so, but my state will never know. That's actually a cool concept. So with Google or Facebook, that wouldn't be possible. They would just record, yeah, he bought like 5 bottles of whiskey last week, so we will give him some ads to buy more expensive whiskey. That's what would happen. Yeah, okay, so in short, what's KILT Protocol? We are basically, do I have it here? Yes, I have it. We are basically a decentralized blockchain system, which is also permissionless, so everybody can just use it, which brings that concept of having an identifier and credentials which are attached to that identifier to the blockchain space. And that's basically our core thing. So you can manage identities and credentials, and those identities can not only be used by humans, but you can also have identities for like cars, for example, or services, machines, assets, for example. A DAD could have an identity, not a DAD, an NFT could have an identity. So yeah, anything that needs identity can have identity and credentials for that. So yeah, but what is then, okay, now we know what's identity. Identity is who I am and the credentials around, but what's actually digital identity? And digital identity is just really an identifier. It doesn't have to be my face. It can just be an identifier plus credentials. This is what it's all about. And what do we take as an identifier? That we take DIDs. So DIDs are just decentralized identifiers. So everybody can issue that identifier to itself. So it is something that comes from you. It's not assigned to you by the state, but you create your identity. You create your DID by generating a secret passphrase, your 12 words, save it somewhere, and derive your identifier from it. And yeah, so the nice thing about that is that the DID is also then, there is cryptographic material attached to that DID, like a public key. And because of that, you can, because only you own that private key, which corresponds to that, you can prove that this is your digital identifier. Yeah, and then we only have like those verifiable credentials. I will call them VC in short. In the next few slides, I will tell that 1 or 2 times. And they are just issued by trusted entities. So like, I mean, the state could issue me my passport, but there could also be like a service which issues me like a credential which says you are the owner of that email, or you are the owner of that Twitter account. And then you have this as a credential and can then prove it to anybody who wants to know that you are not a bot, that you have an email, a Twitter account, and a Discord also. You can just prove it without going to Discord, Twitter, Google to get that information. You get that once, have it as a credential, and then you can just use it wherever you want. So what are DIDs? To just give you like the key information about that. So a DID is just an identifier, and if you look at that here, oh, I can't point it. This is a DID. It looks like a long string, but it's basically just DID, KILT, and this is just a base 58 address. That's what it is. It is unique, so it's just, I mean, you know, it's a public key actually, and if you generate it randomly, it's very unlikely that another person will have that very same identifier. It's not impossible, but it's very unlikely. And yeah, a DID is verifiable, so there are different keys attached to it in the end. So you have, for different purposes, different keys there. And you can also rotate those keys, so you can add new keys when the old ones get leaked or whatever. And so it is verifiable. You can prove your identity to anybody. And it is decentralized. So that identity management, it doesn't even depend on KILT. So DIDs are even bigger. So there is like a whole ecosystem of people out there who care for a decentralized identity, and that DID spec is even an official spec by the W3C now. So yeah, so the W3C, for example, says, what is a DID? A new type of identifier that enables verifiable decentralized digital identity. And this is really from the 1.0 spec. And now, just a little info. What do you think? Who was totally against this spec? Who was against that this spec was written and was released as version 1.0? It was Google, it was Mozilla, it was Apple. They were fighting that because they fear it, because they feel like we are breaking up their monopoly. We are taking the user data back from them and put them back where it belongs, to the users. And that's a threat to them, because it's threatening their business model. And that's why they put much effort into that to actually not let DIDs get standardized. So I think that's a good sign, right? Okay, yeah, and what do we do in KILT? Basically, we have that DID, you can register it on the chain, and then you can get credentials issued to it. And how does it work, actually? So, so we have that blockchain. You can put your DID on it. You can go to attesters, so those trusted entities, so like the state or some trusted entity who gives you credentials. And those credentials are then not just written on chain, so everybody can look them up. No, they are hashed, and only the hash of the credentials is stored on chain. Why do we do that? Because I don't want to share all my credentials with everybody on a public blockchain. That would be like, if I would have a blockchain account and I would just write my banking account, my ID card number, and everything on there, publicly readable, that wouldn't be nice. So we just put the hash there so that everybody, where we show our credential, can also hash it down. So he sees then the information, hashes it down, and then he can check if that hash is written on the chain and who wrote it on the chain. So which attester did it. And this is how it actually works. So why is it written on chain at all? I mean, we could also just create a signature from the attester, attach the signature, and give it out to somebody. Then they could just verify the signature and know, oh, it's from that attester. The problem is, with that way, we couldn't revoke the credentials. Sometimes it's important that you give out a credential, that you give out a credential, and at a later point you want to revoke it because the person left the company, or I don't know, you just don't want that credential to be valid anymore, and then you can just revoke it. Then you write to the hash on the chain, oh, by the way, this credential is revoked. And then every verifier which looks at the credential, looks it up on the chain, sees, oh, there's the hash of that credential, so it was written there. But then as the next step, they look and see, oh, it is revoked. So I shouldn't accept that credential and shouldn't sell Tino that bottle of whiskey. And yeah, that's basically the whole idea besides that. So we have that beautiful standard. We have DIDs and a way to store verifiable credentials. And now what we need is we need applications on top of that. And for this we have like a charter which is called BTE, and they basically build dApps on top of our chain. So we have a few examples. So there's, for example, DID Sign, which is a signing service like DocuSign, but decentralized. There's Social KYC, where you can go and can say, here, I have a Twitter account, I have an email, I have whatever, and then they check that and give you a credential over that. And yeah, so basically, so BTE uses just our SDK to build all those applications. And yeah, why are they good? I mean, they are more cost efficient than the existing Web 2 solutions. Just think about DocuSign. DocuSign costs a lot of money. And all what they do is like creating signatures and storing them. So it's like no-brainer for crypto people. And so that's why we can offer that service for free. And also, in DocuSign, the company behind DocuSign knows about everything. You know, because you have to send the documents there, they manage it, they create it, they log it. I guess they analyze it. I don't know, I don't want to blame anybody, but they could. And yeah, so that's why our Web3 applications have more privacy inherently than the Web 2 counterparts. Yeah, and that's why they are also more secure, because if you don't have like a central place that you can hack to actually get the user data from hundreds or thousands of users, that's like a super nice honeypot for hackers, right? If you know, oh, there is one server which holds like 100,000 records of user data, that's a good target. I would really like spend a lot of energy in hacking this just to get that data and sell it for money. But if we have those information not stored on a central service, but at the user, every user just holds like one set of data records about himself. And that's not an attractive target, you know? You have to spend time and money and energy to hack that one person, and what do you get? You get one row of data. And no one does that, because it's like, I mean, yeah, if that row of data is super valuable, then perhaps, but it's much more likely that a service is attacked where there is much more at stake than like one single line of user data. Yeah. So in the end, I hope we will just replace every single Web 2 application because of those benefits. Yeah, so just as a picture to bring it into your mind one more time, this is how it currently works. We have like that one platform provider, and the user goes there, and their credentials, so their rows of user data, is stored within the platform of the cloud services. And whenever there's like a verifier or a service, an OAuth client basically, they get that information from the platform that has major drawbacks, because the service and the verifier asks directly at the platform. So the issuer of the data is also involved in the identity transaction. So the platform knows that I want to buy whiskey. They want to know in which club I want to go. They just know it, and they will give me ads after that. And so the keys are also just held by the platform provider. And this is really like the main concept how OAuth works. So there's one central place where all your data is, and that data can then be given out in chunks to verifiers, but it always comes from the central platform. But yeah, this is how it's working now. So here we have the user in the center, not the big platform. Actually, there is no big platform anymore. The big platform is the chain, which is above everything, or below here, but get what I mean. So the user here, he has the keys. He holds all its credentials. And he gets those credentials by getting them from trusted entities, from the attesters. So social KYC, the state, whoever. And they give the credentials to the user, and the user holds them. They write, as I said, the hash of the credential to the chain. The user can also verify that its credentials are written to chain by looking at the chain. And then, when it comes to an identity transaction, the user decides which of its data he takes, or which they take, and show it to the verifier. The verifier can then inspect that data, look it up on the chain, if it was really issued, and who issues it, and if it is revoked or not, and can then do it. So I think that model is like 100 times better than that centralized model. Yeah, and it re-empowers the user, because as you see, the user is in the center. The user holds the keys. The user holds all the data, and that's like how it should be. To make it in a little bit more confusing graphic, so here, just really one more time. So how does it work, that whole flow? So here we start with the claimer. The claimer is the user. So the claimer says some claim C. Claim C is, I am the owner of a specific email address. And he gives that to an attester. The tester now looks at that claim. Okay, then he needs to verify, does that user really have that email? He will do so by sending an email which contains a secret code, which the user then has to provide back to prove that he owns that email. You all know that. And then the tester writes the hash of the credential. He writes the hash of the credential to the chain and gives the attestation over the credential, so the verifiable credential basically, back to the claimer. The claimer stores it then locally in its browser extension or I don't know, on his hard drive, and now has a credential. So now, the user can use that credential, share it to verifiers. The verifiers need to do a cryptographic challenge to the claimer to prove that the claimer actually owns the DID, which is written in the verifiable credential. So credentials are always issued to DIDs. So then he knows, okay, I see the credential, I know that the subject in the credential is that user, because only that user can solve that cryptographic challenge. And then the verifier can check the hash of the verifiable credential on the chain, looking if it is revoked or not, and he can decide that he trusts the attester who attested that specific credential. And that's really like the whole flow. That's what it's all about. Yeah, so in the end, basically, DIDs and verifiable credentials make it possible that we have a digital identity which is under our control, which is not our Facebook profile. I think nobody has a Facebook profile anymore, or I don't know, but I think not in this room here. And I will show you through one more example with a new feature, which is currently being rolled out to our testnet and will hit our mainnet very soon. And this is asset DIDs. So as I said in the beginning, not only humans can hold DIDs, but also assets. And yeah, so let's look at that. So for example, in Ethereum, you have the ENS concept. So you can say, okay, you have an Ethereum address, and you can link one ENS to this. So this is already starting to build a bit of an identity. You have like an identifier, and you attach at least a name to it. That's okay. You don't have to remember all those 160-bit addresses from Ethereum, and you can just use that name. That's already a good starting point. But what can we do with DIDs? So with DIDs, so here we have our DID, it starts with that, and we can link different addresses from different blockchains to it. We can link Ethereum addresses, we can link KILT addresses, we can link Moonbeam addresses, Polkadot addresses. This is not a Polkadot address, but get what I mean. So you can link any number of accounts to your DID, and we also have a feature, it's called Web3 name. So you can also link a name to your DID, the same way as you can link an ENS to an Ethereum address. So this is already more powerful. But now, we can even put stuff on top. So, as you might already thought, you can also attach credentials to the DID, which makes it super powerful. And on top of that, you can also define service endpoints for a DID. That's basically, you write publicly into the information of your DID some URLs that you choose. So those URLs could point to credentials. They could also point to your MySpace account, whatever. So you can link a lot of more information to that DID than just the name. So now, the asset DIDs, as I promised. Nearly falling off here. Okay, so asset DIDs. So we start with me, Tino, even with glasses. That's nice. I have a name, Web3 name, and I have some credentials, and a DID. So this is a person. But now we can also have an asset DID. So let's say we have an NFT on any chain from any type. It comes from some contract and it has an ID. So because NFTs normally have like IDs. So the asset DID consists of those types. We just say an asset DID is an identifier which says on this chain, this contract, this NFT. This is, so all those information just concatenated together in the right format form the asset DID. So now we have an identifier for an on-chain asset. And now we can do the very same thing that we did with all the other DIDs. We can add credentials to it. So I, as a person, could issue a credential to that asset. So I could, for example, say, I created that asset. And then I just create that identifier, I create that credential, and since an NFT cannot hold any credentials, because an NFT can't hold credentials, because they don't have a key, they don't have a private key, it just doesn't work. Those credentials have to be public. So you can store that information that I created that NFT publicly on the KILT chain as a credential, which is then also verifiable. And yeah, that's like the basic use case for asset DIDs. So to make it a bit more plastic, here I am a user and I create an NFT. And I create it on an NFT marketplace. And so I created that NFT, and now I just claim creatorship at that NFT marketplace. That NFT marketplace knows that I'm the one who created that, because I was the one who was logged in and clicked on the button to mint that NFT. And then they issue a credential for that asset, which says, Tino is the one who created that NFT. And now everybody, even after the NFT is sold, whatever, can verify who was the original creator of that, without going through a history, and it don't only have to contain the creatorship, but also perhaps what was the company that I worked at the time when I created that. So to, for example, say, this is an NFT which came from the Coda.dot team. You could just issue that once, then the NFTs could live on. Perhaps even the company stops existing, whatever, the credential would stay there, and everybody in the future could always say, yeah, this is the initial creator, and the initial creator is also linked to this company, and so this is an authentic NFT and not like some scam. And it even works with like physical products. So let's say we have a manufacturer which manufactures really, really expensive clocks. So they produce that, a physical good. And as you have seen perhaps with wine, or I think also like watches, those manufacturers start to create NFTs which are coupled to the physical good, so that you can, in an online world, basically show around here, I have that Rolex, I have that. You know, it's always the same. It's like showing it off. And so there's an NFT. And what they also can do is they can issue an attestation which says, I, the manufacturer, built that watch. And they don't attach it to the watch because I think the name of the manufacturer is already written on the watch. But now it's basically also written on that NFT. So now I come and buy the watch. So then the manufacturer transfers the ownership of the NFT to me because I bought the watch. And that's it actually. It doesn't only transfer the NFT, so the NFT ownership now is at me, but the attestation is still attached to that NFT because the asset DID didn't change, because it's still the same NFT. It's in the same contract, it has the same ID, it's on the same chain. And so I can be sure and I can show off, I have that NFT, and it does not only say that I have that super expensive watch, I can also prove it because I have an attestation from the manufacturer which basically shows this is not a made-up NFT from that I issued to myself. No, it is really an NFT which was issued by the manufacturer. So this is just like a basic use case for asset DIDs, but I hope that perhaps the NFT guys here in the room perhaps might pick it up and just come to me and let's talk about that. I think that's a really nice thing that we could also incorporate within marketplaces. Yeah, and that's it actually. Thank you. Here is a list of stuff that we already built on top of KILT. I was asked today if we are live. Yes, we are live. We are on Polkadot. We have like 6 applications built on top. You can just start creating your digital identity, put credentials to it, and start using it. There are already the first websites which accept login via KILT. I think Appian looked also a bit like they are about to support it. Not completely from what I saw, but it looks like it, and it's going into the right direction. And yeah, so thank you. Last slide from our lawyer. It's no financial advice what I said to you. And yeah, legal note, if you want, please read it. Okay, then bye-bye. If there are any questions and time left, I don't know.
It's okay regarding time. So just, yeah, one thing first. It's interesting that you mentioned well, you showed the watch on your presentation, because I think Rolex just entered like the NFT space, like they announced something like recently. So before we go to the questions from the public, I have one question for you. So what are you as a developer most excited about from the future projects? Okay, besides getting a Rolex.
I mean, I'm really super excited for just getting all our data back. So I really want to basically live in a world where I just have custody of all my data, where I just don't have to have a Google account to go to work. I just don't want it. I don't want those central authorities there. I just want to live in a world where I have custody over my data and where I'm not basically taken hostage by those big corporations. I just hope that we can do our part to break it all up and burn it down, basically.
Okay, so do we have any questions from the public? Okay, let's start there. You gentlemen.
Yeah, exactly. So, and I mean, just to follow that idea, basically, if I have a stolen Rolex and want to sell it to you, and you say, I will only buy it if you prove me that you own the NFT which matches that watch, I think you won't have knowledge about all the addresses that the manufacturer at Rolex uses to issue those NFTs, because those will also change over time and so on. But if the manufacturer, if they have a DID is like a long living thing. It's like the identity of the whole company. And if they issue a credential to that NFT, then you can be really sure it's not a made up NFT that I only minted just to prove to you that it's not a stolen Rolex. But then you can be really sure, yes, this is not just a random NFT, this is an NFT which was issued by Rolex. And that's just the extra layer of security on top of there, which comes then from the attestations. I hope that, yeah.
Sorry, just a second. For the live stream, I have to repeat the question. So, to put it shortly, you were asking about the attestation for the DIDs? Okay, so basically, yeah, if you have the attestation only on your laptop, how to use it like once you're on the road? Basically, you have only the cell phone with you.
So we don't have a protocol level solution for that, because that's just not our core business. I can just tell you how I do it. I have them just encrypted in a public Git repository. So I have like my GPG key, which is basically encrypting my stuff, and so I can just sync via Git between my different devices. So, but that's a very personal thing, everybody. I mean, you could also just use a centralized provider for that if you want. I mean, I have a GitHub account. That's not much better. But at least it's encrypted and it's accessible, and yeah, that's really the downside of being like the guardian of your own data. You have to guard it. There is nobody who does that for you. It's the same thing with your seed phrases for your accounts. How do you manage that? It's the exactly same question. So yeah, you have to think about how you back up your data and how you distribute it on your devices. We don't have a built-in solution for that, but I think that is something where we can expect to see some solutions.
Okay, so the next question was also there somewhere. Okay, so to reiterate the question, it was if KILT DIDs are ready in case if the government decides to like implement DIDs or like in wallets, like use it like for example in MetaMask and like different wallets.
I mean, they would be usable for that, but we can't forget that we are just part of a bigger decentralized identity ecosystem. So KILT is not the only DID provider, but we are the one which is the most major, I'd say. So there are a lot of DID providers, there are even some on Ethereum and so on, but I think we are really at a stage, also with all those advanced stuff that we can do. We can have a name, we can have service endpoints and so on. So we are actually ready for that. But I think the first part of the question was also about if they can force me to do that, or did I misunderstand it? So if some authority would come to me and would say, you have to use this technology, I would be very skeptical. And that's why we are building on a permissionless open blockchain. So they can't be forced, so we can't be forced to do stuff. It's just not under our control. It's a distributed system, and people have to vote for every one-time upgrade we do. And if there's a large government or so who wants to push us to do stuff, the community can decide, yes, this is good, then we vote for it, or this is bad, then they vote against it. So I wouldn't like to be forced to use a specific technology, but I'm offering to you all, use it.
Okay, so yeah, at this point I'm gonna stop questions because we are like way over time, but you can find Tino in the crowd and like speak with him directly. So thank you, Tino. Okay. Let's give him another applause because that was like really insightful presentation.